Welcome to our first digital lecture of this course. In this video, I'll talk about bivariate descriptive statistics, which is a follow-up to our discussion from last week on univariate descriptive statistics. So once again, just to review what we talked about last week, we talked about univariate statistics, which really means, as the name implies, statistics for one variable. And in our discussion of univariate descriptive statistics, we talked about central tendency and noted there were three ways to measure central tendency. We looked at the mean, we looked at the median, and we looked at the mode. Emphasizing that for our purposes, we're primarily going to use the mean. We also looked at dispersion, in particular looking at range, interquartile range, and standard deviation. Once again, noting that our major emphasis will be on standard deviation this semester. We then talked about mean, standard deviation, modality, and skew, and noted that we're going to be dealing largely this semester with the normal distribution, which will allow us to eventually hypothesis test with confidence levels and probabilities. But before we can get there, we need to start laying the foundations for thinking about relationships. So in this week's video and in this week's notes, we're going to look at bivariate descriptive statistics. So as we talked about earlier in the semester, we're talking about bivariate, we're talking about two variable in sample, right? That's what descriptive means in sample statistics. And importantly here, for thinking about bivariate in sample statistics, we're really talking about how do we start assessing relationships between two variables, x and y. That is, we're talking about how do we know if there is a correlation between our two elements, x and y. That's what bivariate descriptive statistics, for our purposes, is really going to be all about. So in this week's video, we're going to start with the basic elements, and then we'll add in more of the complex elements following the midterm. The basic elements, as we saw with univariate descriptive statistics, where we looked at frequency distribution tables, bar charts, and pie charts, we're talking about first visualization. Visualization of these relationships, primarily through contingency tables or crosstabs, and then the associated graphs that we can make from two vectors of data. So let's jump into the handout. Once again, I'd recommend you take a look through the handout before you watch the video, just so you can follow along with what we're trying to emphasize in the narrative. So what we have in our handout, as it says on the top, is bivariate descriptive statistics, looking first at contingency tables, or what you'll often see referred to as crosstabs. I'd actually say crosstabs in software programs is the more common label for a contingency table. So once again, we're looking at how do we visualize a relationship or correlation between two different variables. So in the example in the handout, I've got two variables, MH grade, which stands for a mental health grade, and ideology, the ideology of the state. And you can see down here in the note, it says the ideology of the state is based on whether the majority of voters supported Obama, Biden, or McCain-Palin in the 2008 presidential election. So 1's equal to red states, Republicans, and 0 equal to blue states. So if the majority of voters in the state voted for McCain-Palin, the state would be coded a 1. If the majority of voters voted for Obama, Biden, the state was coded a blue state, or a 0 as a Democratic state. It says on the next page, the mental health grade is the quality of the healthcare system for adults with serious mental illnesses, where 1 equals F, 2 equals D, 3 equals C, 4 equals B, 5 equals A. And this comes from, as it says in the note on the bottom, the National Alliance on Mental Illnesses grading the states. So going back to page 1, we can see that I've got a sample, a random sample of 30 US states. And I've got the two variables, MH grade and ideology. Now, intuitively, we would think that perhaps there is a relationship between a state's Republican or Democratic nature and the mental health grade that the state receives. Probably our intuition would be that Democratic states are better at providing mental health services than Republican states, given social welfare spending and social programs. We therefore might think that we should find that Democratic states have better mental health grades. So in that sense, we might consider in our XY terminology that mental health grades is the Y variable and ideology is the X variable. Although it's not super important for what we're talking about right this minute, we'll come back to the importance of defining which is the X variable and Y variable when we get to more complex statistics in a future lecture. Okay, so we can see here that we know our coding for MH grade can take on theoretical values of 1, 2, 3, 4, and 5, and ideology can take on theoretical values of 0, 1. You'll also notice, I'll zoom in a little bit here, that even though the MH grade theoretical values can go from 1 to 5, we actually don't see any 5s. So our observed values of MH grade are actually only 1, 2, 3, 4. And we do have our 0s and 1s for our ideology score. Okay, so once again, we have now two variables, X and Y, ideology and MH grade. We've written down here at the bottom that MH grade can take on 1, 2, 3, 4, 5, although there are no states that are coded 5, so our observed values are only 1, 2, 3, 4, and ideology is coded 0, 1. So from having these two vectors of data, we can start creating our crosstab or contingency table. So what is the purpose of a crosstab? Well, the purpose of a crosstab is to provide the joint frequencies of the variables. So to compare that to a frequency distribution table, a frequency distribution table gives us the count of observations for each value of X. What I'm looking for with a crosstab is the count of each value of X and Y. So for instance, in a regular frequency distribution table, I'm interested in the number of states that are coded as red states and the number of states that are coded as blue states. In a crosstab, I'm still interested in the number of states that are coded as red and blue, but I'm also interested in the number of states that are coded red with a mental health score of 1, red with a mental health score of 2, red with a mental health score of 3, red with a mental health score of 4, Democrat or blue with a mental health score of 1, blue with a mental health score of 2, and so on. And that way we'll be able to visualize, perhaps to some degree, whether or not a relationship exists between these two variables. So how do we set it up? How do we actually create the contingency table? Well, it starts out a lot like we would set up our frequency distribution table. So as it notes on line 2 that we just talked about on the previous page, let's treat ideology as X and mental health as Y. Now, this is going to matter a little bit later on how you set up a table between X and Y. So in general, as a general rule of thumb for a crosstab, we establish the rows as the values of Y, and we establish the columns as the value of x. When we do things like lambda or Summers D, you'll see that it actually does matter for the results that you get which variable to consider x and which variable to consider y. For the crosstab, you can set up either way, but for some of the stuff we'll do later on, it does matter. So it's a good idea to get in the practice of setting the values of the whatever you consider the y variable, the outcome, as the rows. So step one, the setup is identical to the setup we had when we were dealing with the frequency distribution table for univariate statistics. We're simply going to list the values of MH grade. So here I'm going to list the values 1, 2, 3, 4. And even though we don't have a 5, I just list 5 to fill in the table to help visualize what the full table would look like. Okay, so this is exactly the same as the first step in the frequency distribution table. You're doing the same thing you did for x, but in this case for whatever you consider your y variable, listing out the 1, 2, 3, 4, 5. Step 2 is where we get a little bit different than our frequency distribution table. Instead of having the columns represent the frequencies and then the cumulative percent of x and the percent of x, we're going to use the columns to represent the values of x. So in this instance, you can see here that my columns are the values of ideology. So I'm going to list 0 for blue, and I'm going to list 1 for red. Now, if you had a third column or a third value of ideology, let's say that ideology could be mixed, you coded mixed as a 2, you'd simply have another column over here called 2, what we might call purple. And the table would just be a little bit bigger. And you could add as many values as you wanted, 3 green, let's say, and you just extend that table out. But since we only have 2 values, I'm going to erase that. That was just to show you what it looks like if you had extra values. Since we only have the 2, let's keep it with our blue and our red. Okay, so once we have the basic outline of the table set up, we're now doing our counts. So we're filling in, and here's the key part for a crosstab, the joint occurrences. I can't emphasize that enough, the joint occurrences of x and y. So what we're looking for here, I'll kind of highlight as we go, we're looking for how many states are blue states that are also Fs for mental health. How many blue states received a D in mental health? How many blue states received a C in mental health? How many blue states received a B in mental health? How many blue states received a 5 in mental health? On the other side, we're looking at how many red states received an F? How many red states received a D? How many red states received a C? How many red states received a B? How many red states received a 0? So we can, of course, go back to our original data and start counting them up. Let's count zeros and blues. Right, so let's say we want to know ideology 0, blue. Or 0 blue and have a mental health grade of 1. So let's see. Let's look for zeros and ones. Well, we have none. So zeros and ones are 0. What about blue states that receive Ds? Blue states that receive 2s for mental health. So let's look. 04, 03, 03, 03, 03, 03, 03. Oh, here's one. Virginia is a 02. Right, Virginia receives a 0 for ideology, meaning that the way we're coding it's a blue state, and also receives a D for mental health. It looks like Washington is also a blue state that received a D for mental health. Okay, so here for our 02s, we have 2 blue states that received Ds for mental health. How many blue states received a C for mental health? So let's look for 0 3s. Change the color here. 0 3s. Well, it looks like Delaware is a 0 and a 3. Florida looks like a 0 and a 3. Hawaii looks like a 0 and a 3. Maryland, Massachusetts, Minnesota, Oregon, Rhode Island. So we can count up 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 0 3s. Now let's look for 0 4s. Connecticut's a 0 4. Maine is a 0 4. And Wisconsin is a 0 4. So we've got 3 0 4s. And we already said that there are no 5s for MH grades, so we have no 5s. So for the blue states, we have 0 blue and F, 2 blue and D, 8 blue and C, and 3 blue and B. And we'd of course repeat that same process to count the number of red states that had Fs, red states that had Ds, red states that had Cs, red states that had Bs. So you can see here that I've already filled in the table for illustration. We have our 0, 2, 8, 3. Right here. Right, those are blue states, 0, 2, 8, 3. 0, 2, 8, 3. And I've already done the red states. You can count them if you wanted to as well. All right, so in this example, count the frequency of MH equals 1, so Fs, and ideology equals 1, so red. Well, if you went back to the table, Idaho, Kansas, Kentucky, Montana, North Carolina, and South Dakota all receive Fs in our red states. So that's where that 6 came from. So you count those all up, you get 6, 7, 2, 2, 0. So at this point, you have your frequencies basically computed, and you can see here that it tends to look like there are more red states floating around in the lower grades of mental health than there are blue states. Right? So you can see that 6 red states receive an F versus 0 blue states that receive an F. 7 red states that receive a D compared to 2 blue states that receive a D. 8 blue states compared to 2 red states that receive a C, and 3 blue states to 2 red states that receive a B. So you might conclude that perhaps blue states do a little bit better than red states when it comes to mental health grades. Now, just to complete the rest of the table, you'll usually see in a contingency table or a crosstab that additional columns and rows are added just for the totals, for the counts. And this just counts now down the columns. So how many blue states are there in total? 8 plus 2, 10 plus 3 gives us our 13. How many red states there are in total? 6 plus 7 gives us 13. Plus 2 gives us 15. Plus 2 gives us 17. And then along the rows, how many Fs were there? 6. How many Ds? 7 plus 2 for 9. How many Cs? 8 plus 2 for 10. How many Bs? 3 plus 2 for 5. And 0 As. We can then add 13 plus 17 is 30. 6 plus 9 is 15. Plus 10 is 25. Plus 5 is 30. So we have 30 both across the final total columns. This number here, this 30, should always equal n. So as it says here, you'll note that the total cells equal to n if your table is correct. Additionally, you can omit, that is, you can delete the 5 MH grade row because we don't actually have any cases that are there. So generally in SPSS, this row won't be displayed since there are no observations that actually fall in that row. Now, you'll also notice, just like we have in our frequency distribution table, it says here, the size of the crosstab is determined by the number of x values multiplied by the number of y values. So in this case, I've got a 2 by 4 table, which gives me 1, 2, 3, 4, 5, 6, 7, 8 cells. So you'd want to keep these tables fairly small for visualization purposes. Just like we had with a frequency distribution table, you might want to consider creating brackets of values, ranges of values, if you have a large number of values to consider. So basically that's what the crosstab is for. It helps us assess whether or not a relationship exists between two variables by visualizing or summarizing the joint counts of those two variables. Number two, just like we saw with the frequency distribution table, we can represent the information from the crosstab graphically. And the two main ways we do that is through a clustered or a stacked bar chart. So let me just delete what I wrote here to clean it up so we can compare it to our picture. So down here we have our clustered bar chart. This is just displaying now the same information that we have over in our crosstab up here, graphically now down here. So we pretty much set up the same thing that we had in our frequency distribution table, where we can take one of the variables and set that to our x-axis. So it says here that, just the way I've set it up, I tend to think that the variable with more categories should run along the x-axis. I'm using mental health grades as my x-axis. Okay, so my x-axis here is mental health grades. And we know that ranges from 1, 2, 3, 4, 5, or F, D, C, B, A. Now the big change from the frequency distribution table is we need to account for the additional variable. We need to account for the fact that there's another variable in these data, in the data array. So we do that in a clustered and stacked bar chart by giving the values of our second variable colors. So here, very intuitively, I made the zeros, these are the Democrats, or blue states, blue. And I've made the Republican states, or red states, red. And then, of course, we still have the frequency, or the count, along the y-axis. And that's the range of numbers you see in the actual table over here. So we know that the count ranges from a low of 0 to a high of 8. So here we've got 0 and our high value of 8. Then it's simply a matter of plotting the correct sort of bar for the observations in the table. So you can see here, how many blue F's do we have? Well, 0, so we don't need to plot anything. How many red F's do we have? Red F's, we've got 6 red F's. So here under our F, we've got 6 red F's. And this bar represents the data from this cell. How many blue D's do we have? Well, according to our table, we have 2 blue D's. So you can see here, our blue bar goes up to 2 for 2 blue D's. How many red D's do we have? 7. So here, our red bar under D's goes up to 7. How many blue C's do we have? Well, we have 8 blue C's. So here's our blue C bar, that goes up to 8. How many red C's do we have? 2. So we've got our red C bar that goes up to 2. How many blue bees do we have? We have 3. So they go up to 3. How many red bees do we have? Well, we only have 2. And then, of course, we have 0, 0 for our A's. So once again, the clustered bar chart is simply the graphical representation of the data from our table. Now, the one thing you'll notice down here, and why it's called a clustered bar chart, is that the bars are literally clustered or positioned right next to each other. So this cluster, which even though there's no blue, represents your cluster of F's. This is your cluster of D's. This is your cluster of C's. This is your cluster of B's. And we have no cluster of A's. Okay, so literally the bars are clustered together or next to each other to represent that, look, there are more red states in the lower range. Right, here's our red, red. There tend to be more blue states in our upper range, our sort of 3s and 4s, our C's and B's. So clustered bar charts allow us to color code the different groups and then look for visualization of relationships between our 2 variables in graphic form. The alternative, and once again, this really depends on how you think the data are best visualized, are stacked bar charts. In a stacked bar chart, and we'll erase some of the stuff that we have down here. In a stacked bar chart, we are literally simply going to stack these bars on top of each other. So there's nothing to stack on F's, but here we're literally going to stack the red bar on top of the blue. We're literally going to stack the red bar on top of the blue. We're going to stack the red bar on top of the blue. So the one thing that's going to do is it's going to get rid of the clusters, but it's also going to make the y-axis larger because we have to account for the combination of the 2 plus the 7. So this will be 9. We've got the 8 plus the 2, so this will be 10 observations total. And this will be 2 plus the 3, so that's going to give us 5 total. So we're going to have to make this axis a little bit longer to account for the fact that the stacks are going to get taller. So you can see here that on the next page, we've now gone up to 10 on our axis, and we've literally stacked the bars on top of each other. So here you can see that you still have your 2 blues for D's, and you still have your 6 reds, right, for D's. But instead of putting those bars next to each other, they're now stacked. You still have your 2 reds for C's, and you have your 8 blues for C's. And here you still have your 3 blues for B's, and you still have your 2 reds for B's. Same information, just slightly visualized differently. Once again, you pick the one that looks the best for the information you're trying to convey. Okay, so crosstabs, very useful. Crosstabs and clustered and stacked bar charts tend to work best for nominal and ordinal variables. If you have a continuous variable, it's best to recode the continuous variable as an ordinal variable, making the collapsed categories. So once again, that really helps reduce the number and size of the tables and improve the visualization of your data. Moving on to number 3, this is something that a lot of people are already familiar with. We've got scatter plots or scattergrams, and this is where we want to visualize 2 continuous variables. So once again, we have x, y, and we're going to treat each pair of x, y values as coordinates in the x, y grid system. All right, so think about the grid system. I'll remember this from probably elementary school. Here we take an x-axis, we take a y-axis, intersect them. We have an origin probably at 0, 0, and then we can create grids by which we plot our points. So just for our example here, let's look at some continuous data. I've got one variable, let's say our X variable, which is the number of broken bones a individual receives from their first encounter with a costume vigilante known as the Batman. And let's say our second variable is Y, the number of felony convictions since their first encounter with the Batman. We might call that recidivism. So we might have a question, does a run-in with the Batman reduce recidivism? Well, we can look at data and assess basically how severe your encounter was with the Batman against how many new felonies you were convicted of since your initial encounter with the Batman. So I have here, as just some example data, a list of people, a list of typical Batman villains. You can kind of take a look at and try to guess what their criminal names are. And we have then our variables, X, the number of broken bones in your first encounter with the Batman, and basically your recidivism rate, the number of new convictions you've received since you encountered the Batman. So once again, we're thinking then about creating that XY axis. So here we can have that 0, 0, and we can make life a little bit easier. Let's do this by tens, 10, 20, 30, 40, 50. And we can do bones actually has a lot, so let's do these by 30s, 30, 60, 90, 120. All right, so once again, then you'd plot here. Number of broken bones. I ran out of room for the first guy. That's the second guy, Arthur Brown. He's a 27 and a 5. So let's get a blue point out for him. 27 and a 5 would be somewhere right about here. 34 and a 7, so 34 and a 7, right about here. 111, so somewhere over here, and 22, so somewhere right about there. And we, of course, would want a bigger area to plot. We could plot all these values. I've done that in Excel over here, same idea of the coordinate system, plotting the recidivism rate, and you can see here, everybody plotting that produces a pretty strong positive relationship. We're going to draw that best fit line, something like that. So it looks like, in fact, that people who have a bad first encounter with the Batman actually tend to commit more crimes. So there is a correlation. Those who receive more broken bones in their first encounter with Batman tend to commit a higher number of new crimes following their first encounter with the Batman. So scatter plots, something you've probably done quite a bit before. I imagine you did it since 5th grade and on in your sort of primary and secondary education, and probably a little bit in college as well. What is probably a little bit new to some people is our final sort of topic for this group of slides, which is time series. The big difference here with time series data is we're typically considering the time variable as the X variable. Okay, so in this case, I'm using a survey data from Franklin and Marshall College poll. Here, the X variable is the month year. So you can see here, January 2010, February 2010, March 2010, May 2010, et cetera, et cetera, et cetera. One of the things that's important is that the time intervals are predefined and consistent to make this work. So here they are, the month, year. You can see here that we pretty much run the survey through January through August, then January through October, March to October, January, and so on. The actual Y variable is a question, head in the right direction. So this is the percentage of survey respondents that responded favorably to in all, do you think things in Pennsylvania are generally head in the right direction, or do you feel that things are off on the wrong track? Okay, so we have, once again, our time variable. We've got our actual values of our Y variable, and we can then create a plot of our data. So here our x-axis is our time variable, our y-axis is our y variable. I've converted the dates to simply numbers, so we have a bunch of time periods, and the actual values for the server responses. So you can see here that we've got sort of a lot of jagged lines, right? Looks like a decline here, but then an uptick, right? So a plus line here, then another decline, negative, a little uptick, more negative, big uptick, more negative, another uptick, flat, negative, negative, positive, negative. So, it's hard to visualize, what's going to happen, right? Because there's still data in the future that we don't know, right? There's data out here, which is the big unknown. Is it going to continue to go down, or are we going to see more of an uptick, right? Which one is it going to be? So as I write in the handout, the authors of the report think these data represented trouble for Governor Corbett in the 2014 election. They highlight that the percentage of favorable response hit an all-time low in August 2013. But the real question that we have, which is noted down here, is there a negative trend in these data? Well, as I write, it's difficult to see because political polls are volatile. That means there looks like there's cyclical trends in the data. There are several troughs and several spikes, as we just saw, which may distort our interpretation of the results. So oftentimes with survey data, the most basic solution is to smooth the data, which involves some sort of local averaging to try to eliminate the spikes and the troughs. So the most common average to smooth the data is what we call a moving average. And a moving average is where we replace each observation either with a simpler weighted average of n observations surrounding the initial observation. That sounds complicated, but let's take a look at the formula. MA, meaning the moving average for observation I, is equal to the value of xi plus the value before it plus the value above it divided by 3. So what we're saying in this simple example is we're going to replace each individual observation with the average of that observation with the period before and period after it. So let's flip the page and look at the example. This is our original data in the first two columns. Here's our x, here's our y. So we're looking at January 10th, head in the right direction, 39, February 10th, 37, March 10th, 32. I've added in the time periods I, 1, 2 through 16. So looking at our formula, moving average is going to be I plus I minus 1 plus I minus 2 divided by 3. We can't have an observation here for the first one because there's nothing to add before our first observation. So that one's a blank. But our second observation, so when the moving average I equals 2, we're saying let's take the 37, the 39, and the 32. Let's add these together and calculate that average. So when we calculate that average out, as it shows you down here in the example, we get an average of 36. And then we simply keep doing that for every observation. So for our third observation, 32, we're going to take that 32, we're going to add in the 37, add in the 35, that's going to give us the 34.7 when we divide by 3. For our fourth observation, we're going to add the 35, the 32, and the 30, and that's going to give us, when we average that out, a 32.3. For our fifth observation, we're going to add the fourth observation, the sixth observation, average those together, and that's going to give us 32. And we're going to keep doing this all the way down the list until we get to our final observation, which we can't add something ahead of it because there's nothing ahead of it, so we also have a blank there. So our moving average is a little bit shorter in a series, but now we've averaged away some of the really rough spikes and really low troughs. So when I plot the moving average for our 3 observation moving average, we get this graph. So now here you can see that this first time period is much more negative. We still have a positive period, but then we see a much sharper decline in the negative period. So once again, this is our smooth version of the graph. And you can compare that to the previous page. We have a lot more jaggedness, right? So we've kind of eliminated in this period these kind of spikes and troughs here, eliminated this spike here. We've kind of smoothed some of these out here. Right, so now we have that smooth curve that shows a sharp period of decline, a period of increase, and then another sharp period of decline. So naturally, the more jagged your data, the more useful the smoothing technique will be to help you identify patterns. And here it looks like, it is kind of showing much more cleanly now that the negative point that we reached in the last period is the worst period in the series for approval. Does it mean there can't be an uptick in the future? Well, of course not, because if you only looked at the series up until this point, you'd conclude perhaps it continue to go down, but in fact actually got better. So you don't want to make too much of a trend that's kind of looks cyclical up and down, but you may be able to get more leverage over what you think is going on by smoothing out some of the rough peaks and troughs of your data. The other important thing thinking about how to handle time series is while smoothing will allow you to identify trends such as highs and lows, another useful thing to consider when looking at time series data is to look at differences. Mainly because the problem with time series data, as it says in the notes, is that they're not statistically independent. Now, I don't want to get into a lengthy discussion of what that means here, but the intuition is that if I observe something in a series at time 2, the value I get is often dependent upon the value at time 1. Corbett's sort of approval rating tomorrow is largely going to represent what his approval rating of today was. We don't see a lot of drastic change because we call what we've essentially called path dependence. That once you're on this path, we see variations along the path, but you're not going to see a massive shift over values because they're all belong to some similar continuous process. So another solution to thinking about the lagged effect or getting rid of the lagged effect of time series data is to calculate first differences in the data. So here in page 8, we looked at the actual data and plotted that to try to gain sense on how the trend is moving towards Corbett opinions. But another solution here is to calculate the difference between the time periods. In other words, are we seeing bigger jumps in the negative compared to jumps in the positive? So here we have time period 1, time period 2, 37 to 39. What is the difference? The difference is a -2. Approval ratings dropped or opinions dropped. How did it look from time period 2 to 3? So we go from 37 to 32. That's a drop of -5. From March to May, we see an increase of 3, but then another drop in 5. An increase in 1, but another drop in 4. We see a jump in 10 points, but then a drop to 3. Okay, so we can look at first differences instead, and then kind of visualize, are the negatives, right here are the negatives, more indicative of decline in Corbett approval than the positives? So one way to do that is to graph out these sort of changes here, and you can see that it's a lot of spikes and troughs, but what we're trying to assess is, are there more points down here below the line than there are points above the line? Right? You can see here that really what's happening when we start thinking about the plus minuses is that a lot of the peakedness is coming from that big jump between time period 6 and time period 8. So at time period 7, we see the biggest jump, right? So going back to our original data, we see that 10-point jump in March 11th that is really driving perhaps a lot of that cycle that we're seeing here. It was really that 10-point jump, this big jump here, that's really contributing to why we see maybe that peakedness that's coming down. So once again, first differences will give you a slightly different perspective on how to analyze time series data. And of course, you can make that percentage if you wanted to by simply taking the percent difference and then calculating it as a percent, which the rest of the handout talks about. So once again, take a look at the handout. The real takeaway points from the handout really are, we're trying to visualize relationships. If you have nominal ordinal data, the best way to visualize relationships is through the use of a crosstab, and then you can always turn that crosstab into clustered and stacked bar charts. If you've got continuous data, you can then create scatter plots or scattergrams to visualize the data. And if you have time series, you probably should use perhaps some kind of moving average to smooth out the troughs and the peaks, or take a first difference model to really help you visualize the highs and lows or the ups and downs of those data changes. So if you have any questions, I'm going to open up a Dropbox for the week, and feel free to type any questions into a Word document about what's in the handout or what's in the video lecture and pop those in the Dropbox.